Hey, Algebra 1 students, I am on lesson 2.9 and going to walk you through this lesson and solve one of your problems for you. So go ahead and start on page 83. Um, this is a tricky lesson, so it is in your best interest to definitely read all of the introduction pages and really kind of work through the examples as you go. You'll see that the title is called Solving Mixture Problems. And basically, as the definition says it, mixture problems are word problems with items of differing values combined to form a whole. So it's items that are worth different things that all have to come together to equal the whole number, which the story problem will tell us. These can be really tricky to set up. So the authors kind of want you to use this table format or this chart format. And that's the very, very first thing that they break down for you. Table A kind of shows you there's a quantity column, there's a value per units column, and then there's a total value column. And the idea is that as you walk through the story problem, you'll be able to break those components out and make it make sense. These problems would be substantially hard to solve if you did not break this information apart, because practically every sentence is telling you something important that you'll need to use. So number one is going to be the only one that I'm actually going to solve for you. If you look over to pages 88 and 89, you'll notice that 1, 2, 5, 8, 9, and 13 have the blue flags over the numbers. So those are going to be the only problems that you're going to solve from the practice section. And then from the review, you're also just going to solve the blue flagged problem. So you don't have a ton of problems in this lesson. I did that on purpose so that you would have plenty of opportunity to focus on the problems that I want you to get correct. And I'm actually even going to solve one problem for you. So the problem that I'm going to solve for you is very similar to the first two examples. It kind of follows the same format as Table A and Table B, and it's similar in nature to example 2.9a, a little bit similar also to 2.9b. But as you look over at like example 2.9c, that's going to be a percent problem. That's an investment or simple interest formula problem. And so when you are looking back at, say, for example, number 8, you're going to need to refer to 2.9c as your example there. And I'm not going to work that one as an example for you because I'm going to do one and then let you sort of apply that knowledge to the rest of these problems. I want to see what you're able to do, and I don't want to get caught up in working a lot of your problems for you. So I'm only going to do number 1 today. Number 1 is pretty complex, so it'll take us a moment to work through this problem, but we'll get through it, and then that hopefully will give you a frame of reference for how to solve the rest of the problems. So let's just first read the problem together. A cashier has 26 bills. We don't know what they are, but we know there's 26 of them, consisting of 3 times as many ones as fives, 1 less 10 than fives, and the rest 20s. If the value is $120, find how many of each she has. Okay, so if I'm starting off, I know that there are 26 bills all together. So that gives me a starting point and gives me a place to begin. That's kind of what everything will revolve around, is that number of 26. And I get the first breakdown, 3 times as many ones as fives. Well, I don't know how many fives there are. How many fives are there? So when I'm trying to discover how many $5 bills I have, that is my unknown. So therefore, I'm going to make this my X. So I'm going to start creating a chart, and I'm going to see if I can use my chart to help clarify my information. First, I know I have ones, okay? I'm just going to go across the chart like this. And the first thing I need to figure out is how many, what is my quantity? And again, this chart is similar to the charts that you saw in the first few pages of the lesson. So first, I'm going to cover the quantity. And it says 3 times as many ones as fives. Okay, so fives are my unknown. So 3 times as many would be 3x. Okay, and what is this unit? Well, the unit, what does my $1 stand for? It just stands for 1. That's its value. That's how money works. So if I wanted to put a total value on just that statement, then my 3x, I could say 1 times 3x, but that's really, if I want to come over here and do the math, I could say 1 times 3x, but really I'm just going to get a 3x as my total. So there you go. I figured out something to represent the ones where it says 3 times as many ones as fives. Okay, the next one says 1 less 10 than 5. So because I want to go in order, let's just go ahead and knock out my 5s. And this one should be super easy because we said already up here that 5 is going to equal x. So I'm just going to put this x in because however many x's there are, that's my 5s. And we know that the unit here is a $5 bill. So if I multiply 5 times x, then I'm just going to end up with a 5x. Okay, so I've completed that portion of my column. I can bring this down a little. Okay, 1 less than 10, 1 less 10 than 5s. Okay, so now I'm talking about tens. I'm talking about $10 bills. Okay, and it says 1 less 10 than 5. So 1 less 5 is, x is my 5, so I'm just going to say 1 less. And what is the value of a 10? Well, it's 10. That's just the way money works. So I actually have a situation here where I have 10 times x minus 1. So I can just rewrite that. I'm just making it look better. And I'll put my parentheses in. And that's as best as I can do. I can't really combine it any other way because what's inside the parentheses is an x minus 1, so I can't clean that up. And then the last one is my 20s. It says, and the rest 20s. Okay, so whatever and the rest means, but I'm going to put in my $20 sign. So basically, whatever's left, it's going to be 20s. So right now, I have 10, I have a 3x and a 5x and a 10 times a negative or x minus 1. I kind of have all this happening here together. So what I'm going to do is my total is 26 bills altogether. So when it says, and the rest is 26, I need to start with 26. I'm going to start with the 26, and then I'm just going to subtract off everything I've already used. So I'm going to subtract off 3x plus 5x. I'm probably going to run out of room. Plus, I'm sorry, actually it just needs to be, let me not confuse myself. It would be 3x. I'm looking at this column right here. This is my quantity. So I'm going to subtract off 3x minus x, or plus x minus 1. So I'm going to restate what I did here. Okay. All I did was I know that I have a total of 26 bills altogether. So this quantity is like how many bills. Oh, this is like horrible writing. I'm struggling with my mouse today. How many bills are right here? That's my quantity. How many bills? Well, I use certain amount of bills for my dollars, and I've used a certain amount of bills for my $5, and I've used a certain amount of bills for my $10. Okay, for my $10 bill. So I know that I have 26 total. So I'm just going to say 26 minus the combination of all that other stuff. And that's what that actually says. 26 minus the quantity of 3x plus x minus 1. And we know those are the 20s. So I want to kind of clean this up. I'll just bring this math down here. I have 26 minus 3x plus x minus 1. Okay, so I'm going to clean this up just a little bit so that it just looks better, more or less. And so I'm going to say there's a negative 1 here. I'm going to have to factor it out, but I can actually combine all these to have a 5x. Okay, so I'm just going to turn all this into 5x minus 1. And now I have a negative 1 outside here and a 26 minus all this. So I'm going to just factor. Negative 1 times a positive 5x is going to be a negative 5x. And then a -1 times a -1 is going to be a +1, and I can just bring down that 26. I've jailbroke my parentheses now, and I can just combine like terms, which is a 26 and a 1. So you can either say -5x plus 27, or if you want to say 27 minus 5x, either one is fine. It's just kind of the same thing. Okay. And then you're going to multiply all of this by this 20, because see, we multiplied this by that. We multiplied this right here. We multiplied the 1 times that. So I'm going to have 20 times, it doesn't really matter, but I'll keep it as clean as possible. So 27 minus 5x. So that's what's in my actual chart. Okay, that's what's in my actual chart. And you notice that it took me a little bit just to get to that. So I'm going to go ahead and just erase all this extra stuff so that I can have some room to actually now solve my problem. So now that I have completed that much, I'm looking at this information in my total to build my equation. Okay, I'm going to use this information to build my equation. And I want to go back to how much the value of everything is. So if you keep reading the very next line, it says, if the value is $120, find how many of each she has. So what I need to do is I must add each of these together and basically set it all equal to 120. That's what she's saying. Like, if I can figure out what my X is, then I know how many ones I have, how many $5 bills I have, how many $10 bills I have, and how many $20 bills I have. So I'm literally just going to add all this up and set it equal to 120. So here's what that looks like. 3x plus 5x plus 10 times the quantity of x minus 1 plus 20 times the quantity of 27 minus 5x equals 120. Now, this might look like a complicated problem, but this is the easiest part. The hardest part is by far setting up this table. And unfortunately, if you don't set the table up correctly, there's absolutely no way to go ahead and solve the rest of the problem. So setting up these tables and reading the examples on how to set up these tables is extremely important, because if you can't set the table up, then you have absolutely no idea how to create this mess. Once you create the mess, it's pretty easy. Like, I'm going to start here with, I have some parentheses to deal with here and parentheses to deal with here, and there's nothing I can do inside these parentheses. So I can just go ahead and factor. And if I want to factor both at the same time, you can do it in separate steps, or if you want to do them both at the same time, if you feel savvy enough, you can do that. And I want to, just for time management. So I'm going to copy down my 3x and my 5x. I actually could have combined those x's too, but I'm going to have more x's to combine anyway, so it's completely fine. So 10 times x is 10x. Positive 10 times a -1 is just a -10. And then 20 times 27, I already cheated and I know the answer is 540. So I knew that one. I didn't know it off the top of my head. And then 20 times a -5x is a -100x. So I have a lot of x's now to combine, and everything still equals 120. Okay, so if you take 3x and 5x, that's 8x. If you take 8x and you add in 10x, now you have 18x. So if you take a -100x and you add a negative to all of that, then you're going way on the other side of the 0 on the number line, and basically you end up with a -82x. So a -82x. And then if you want to combine like terms on this -10 and this positive 540, then you're going to end up with a positive 530. So 530 equals 120. Now, of course, I want to start getting this x all by itself. So I'm going to subtract 530 from both sides. And you know the rule is here is what you do to one side, you must do to the other. And of course, these are going to cancel, and that's the whole point. So we have a -82x and then equals, and that's going to be a -410. So, you can use your calculator here, and obviously the negative is going to go with the larger quantity, which is 530. And now at this point, I have to get the 82 off that x. So I'm just going to divide, because it's the opposite of multiply, and take the negative with me so that I can just cancel out negatives as well, because these are going to go away. And this is going to be x equals, and a negative divided by a negative is a positive. Of course, it has to be a positive number because we're trying to figure out this original business right here, which is how many $5 bills are there. Because if I figure out how many $5 bills there are, then I can do the math on everything else. So if I take 410 divided by 82, it's actually 5. So I actually have 5 fives. Okay, that's kind of crazy, but I have 5 $5 bills. I have 5 of them altogether. Now, so the trick here is it says a cashier has 26 bills consisting of 3 times as many ones as fives, 1 less 10 than fives, and the rest 20s. If the value is $120, find how many of each she has. So I'm going to need to check here. I'm going to have to like check my work and make sure that I have done it correctly, and then I can move on and tell you how much I have of everything. So right now I believe that x equals 5. So in order to check it, I need to just come up here and resolve the problem. So I'm going to start with this one again, except for every time there's an x, I'm going to put a 5 in there. Okay, so here's 3 times 5 plus 5 times 5, because there was an x there, so I'm going to put a 5 in, plus 10 times 5 minus 1, plus, oh goodness, don't run out of room, 20 times 27. And then I'm going to go ahead a little bit because I'm going to run out of space. But 27 minus 5 times 4 is 20. Okay, so I'm just going to go ahead and do that. I'm sorry, 5 times 5 is 25. 5 times 5 is 25. And so I'm going to change this. I don't need it to be 5 times 4. I need it to be 5 times 5 is 25. And then all this equals 120. Ooh, barely. Okay, 3 times 5 is 15 plus, so ugly, 5 times 5 is 25 plus 5 minus 1 is 4, times that by this 10 right here, and that's going to give me 40, plus 27 minus 25 is 2, times 20 is also 40, so 120. And then when I add these up, 40 and 40, and then 15 and 25 is going to be 40. So that's going to be 40 plus 40 plus 40, which is 120 equals 120. So I know that I found the correct value for my x. So now the only thing I have left to do is say how many fives, how many tens, how many ones, and how many 20s I have. Okay, so we already know that x equals 5. So as far as my $5 bill is concerned, I'll go back to like this color. So for I'll just kind of make a little chart for $1 bills, for $5 bills, for $10 bills, and for $20 bills. Okay, for $5 bills, there's 5 of them. We already know that. Okay, for $1 bill, it said it's 3 times 5. So 3 times 5, that means that there are 15 $1 bills. For tens, it was 10 times 5 minus 1. Well, 5 minus 1 is 4. And 10 times, there's 10 times 5 minus 1. So 5 minus 1 is 4. And then 10 times 4, there are 4 $10 bills. So I want to make sure I'm telling you this right. I don't want to use this one. I want to use this one. Okay, so 3 times 5 is 15 because that's where just my single x is. X is a 5, and now x minus 1, because in the problem it said 1 less 10 than 5. So x minus 1, that means there's 4 tens, 4 $10 bills. And then this whole big mess, which we cleaned up earlier, was actually, if you remember, it was 27 minus 5x. So 27 minus 25, so there's 2 $20 bills. Okay, so this is actually your final answer. This is it right here. So there are a lot of steps. So for my guys who do not like to show steps, I'm making you do 5 of these because I did one for you. and you're getting this one totally for free. I need you to show me everything you're doing because I need to know if you actually know how to do this or what you might possibly be missing. So please go ahead and be very thorough on lesson 2.9 and take the time to solve all 5 of them by showing me your steps. If it takes you an entire piece of paper to solve one of these, that's kind of quite all right. And then when you do the review, you have to do 1, 2, 5, and 11. Okay, simple stuff, and you're finished with the review. I was light on problems for this lesson so that you could actually show me that you know what you're doing. They're difficult. If you get hung up on one, email me and I'll make a whole class video, but I want to see what you know. Good luck.